Section 6.2 looks at the second method that we have for solving systems of equations, which is called substitution. Alright, so we have 3 steps. You have them there in your notes. These are from the book, so they're kind of in a little bit of formal language. So as we go through some examples, if you want to maybe rewrite these in your own words or add some things that make sense to you, that's probably going to be helpful. So we're going to solve an equation for one variable, and we'll talk about what variable and why as we go through some examples. And then when we get it solved for one variable, we're going to substitute that into the other equation. So this is going to make a lot more sense if we look at some examples. So here we have the first example, and our system is right here, y equals 2x plus 1, and then 3x plus y equals negative 9. And like we said before, step 1 was to solve one equation for one variable. Well, that's already done for us. The first equation already has y by itself, so step 1 is actually done for us in this equation, so we're going to move to step 2. And remember, step 2 said we were going to substitute that expression into the equation. So what I'm going to do, I'm going to take whatever's on the other side of the equal sign. So in this case, 2x plus 1. Alright, and I'm going to put it in place of the y because this is equal to y. So I'm going to put it in place of the y in my second equation. So now instead of y, I'm going to have 3x plus 2x plus 1, and that's going to be equal to negative 9. So I took the second equation, alright, and I replaced the y with this up here from the first equation. Now this is an equation with one variable, just the x's, and we know how to solve this. So I have like terms that I need to combine. 3x plus 2x is 5x plus 1 equals negative 9. Then I'm going to subtract 1 from both sides. I get 5x is equal to negative 10, and then I divide by 5, and x is equal to negative 2. This is 1/2 of my ordered pair. Remember, the solution to a system is always an ordered pair, so negative 2 is 1/2 of my answer. To get what y is equal to, I need to go to step 3. And step 3 is to take the number that I got from step 2 and plug it back into an equation to find y. It doesn't matter which equation you use, but if you take a second and look at it, you'll find that some of them might be easier. So like in this equation, it probably makes more sense for me to put negative 2 here because it's already solved for y. So I'll just do the math over here, and then I'll get what y is equal to. So that's what I'm going to do. So y is going to be equal to 2 times negative 2, because I know that x has to be negative 2, plus 1. Alright, so 2 times negative 2 is negative 4, plus 1 is negative 3. So the solution to this system is negative 2, negative 3. If you were to graph that on your graphing calculator, you should get negative 2, negative 3 as the answer as well. So substitution is a different way to get the same answer that we would if we did it by graphing. Alright, we'll take a look at a second example. So I have x plus 2y equals 6, and then 3x minus 4y equals 28. So this time, neither equation is solved for a variable already, so I have to do it for myself. You can pick any variable in any equation and you will get the same answer. However, it is usually easiest if there is one that already has a coefficient of 1. So either it has a 1 in front of it or it doesn't have a number in front of it at all. That's the easiest one to solve for because you don't have any division, so you don't have any chance of creating fractions. So what I'm going to do is I'm going to take that first equation, x plus 2y equals 6, and I'm going to go ahead and solve for x. I'm going to get x by itself. So I'm going to subtract 2y from both sides, and I have x equals 6 minus 2y. Alright, from here on out, this is just like the first example that we did. So step 1 was to solve for a variable. Step 2 is to substitute. So I have 3x minus 4y equals 28. That's my second equation. I'm going to take this whole expression, everything on the other side of the equal sign, I'm going to plug it in this time for x. So where there's an x in this equation, I'm going to replace it with the 6 minus 2y. So now I have, instead of 3 times x, I have 3 times 6 minus 2y minus 4y equals 28. Alright, so I took the x out and replaced it with this expression. Now, again, all I have in this equation are y, so this is an equation that we should all know how to solve. I'm going to distribute first. So I have 18 minus 6y minus 4y equals 28. I can combine like terms here, so 18. Negative 6 minus 4 is negative 10y equals 28. I'm going to subtract 18 from both sides. Now I have negative 10y equals 10. Divide both sides by negative 10, and y equals negative 1. So again, remember your solution to a system is always going to be an ordered pair. Alright, y is equal to negative 1. Negative 1 is the second number in an ordered pair, so I know it's something negative 1. To figure it out, I'm going to take this number, negative 1, I'm going to plug it in for y in one of these original equations. Doesn't matter which one. I'm going to do it in the first one because the x has a coefficient of 1, so I don't have to do any division. So I have x plus 2 times 1 equals 6. 2 times 1 is 2, so x plus 2 equals 6. If I subtract 2 from both sides, x is equal to 4. So my solution is 4, negative 1. And again, we're going to check these either by plugging 4, negative 1 into both equations and making sure I get a true statement both times. Or if you want to graph it on your calculator and have your calculator find the intersection, you can check it that way as well. Okay, so you have 2 more examples there. I'll walk through one of them with you, and then I'm going to have you try the second one on your own. So 1a we're going to do together, y equals 4x minus 6, and then 5x plus 3y equals negative 1. Already solved for y, so I'm just going to go ahead and take this expression right here, and I'm going to replace the y with this whole thing. So I have 5x plus 3 times 4x minus 6, and that's going to be equal to negative 1. Alright, then to solve this, I'm going to distribute first, so 5x plus 12x minus 18 equals negative 1. Combine my like terms, 17x minus 18 equals negative 1. Add 18 to both sides. 17x equals 17. Divide both sides by 17, and x is equal to 1. So I know 1/2 of my ordered pair, it's 1 comma something. To figure it out, I'm going to take this 1 and plug it in for x. I'm going to choose the first equation since it's already solved for y. So y is going to be equal to 4 times 1 minus 6. 4 times 1 is 4. 4 minus 6 is negative 2. So y has to be negative 2. And then I'm going to check that on my calculator. So I'm going to put both of these equations into the calculator, 4x minus 6. And now for the second equation, in order to check it in the calculator, I have to actually solve for y. So I have it here, and I got to subtract 5x from both sides. 3y is equal to negative 5x minus 1, and then I'm going to divide everything by 3. And I get y equals negative 5/3 x minus 1/3. So that's what I'm going to type in the calculator. Negative 5/3 x minus 1/3. Go to my graph. It's going to draw both of them. Then I'm going to ask it to find the intersection. And it tells me that it is 1, negative 2, which is what I got when I did it by substitution, so I know I'm right. Alright, you have this second example. I want you to pause here, try this problem, and then come back and check your answer. Alright, so hopefully you got 4, negative 1 as your answer. The work is in blue, where I solved, and then in red I went ahead and checked it that way instead of by graphing. Doesn't really matter, you can check it either way, but I do want you to check your answers every time, either by graphing on the calculator or plugging in the answer that you got. Alright, so if you have any questions there, make sure you write them down so we can talk about them in class and go back and put them on the Google form as well.